Hi everyone, this is the Chapter 5 exam review for Algebra 1B. This first video is just going to cover this first page, which really focuses on solving systems. And up here where we say using the method of your choice, remember the two methods we're referring to are substitution and elimination. Okay, and you can choose whichever one works best for you. Okay, and you may choose differently than what I'm about to choose. I tend to look at a problem and just kind of decide which one's easier for each individual problem. So you'll see me kind of hopping back and forth. So for example, in this first one, I see that both equations have y by themselves. Anytime you have a variable by itself, substitution is probably going to be your easier way to go. So in this case, because I have y by itself in both equations, I can start with either one. But I want to take what y is equal to here and plug it in place of the y variable in the other equation. Okay, so then I'm going to take this equation and rewrite it, and I end up with x plus 1 equals 2x minus 3. And now I'm going to solve that just like any other equation. So I want to get my x's together, which means I'm going to subtract an x from each side. So now I have 1 equals 1x minus 3. Again, I want to get that x by itself, so I'm going to add 3 to each side. And I get a value of 4 for x. So that's sort of half my battle. Now, I still need to go back and find y. To find y, I'm going to take my x value and plug it into either one of my equations. And in this problem, because they're both solved for y, either one of them's fine. I'm going to go with that bottom one just because it looks easier. So to find y, I would take y and say y is equal to x plus 1. And we just said that x was 4, so 4 plus 1, which means y must equal 5. Okay. And so then my final answer would be the coordinate 4, 5. Okay. So let's look at the next one. The next one's really similar. Again, I'm going to take what y is equal to and plug it in for y in the other equation. So that leaves me with x minus 5 equals 4x minus 5. I'm going to start by getting my x's together. And because they're on different sides of the equals, I have to subtract to do that. So I'm going to minus x and minus x. So now I have negative 5 equals 3x minus 5. So I've moved all my x's to the right. Now I'm going to go and move all my numbers to the left. So I'm going to add 5 to both sides. Now this step freaks a lot of people out. I've got negative 5 plus 5, which technically cancels out, but I need a number there because otherwise I don't have anything else written there. So this is really a 0 now, and this over here is just a 3x. Now, don't get carried away thinking that that means it's like no solution or anything like that. 0 is a number just like anything else. So any other time in this step, the next thing I would do is divide by 3. Divide by 3. And 0 divided by 3 is 0, so I get 0 as my x value. Okay, perfectly valid answer there. And now I'm going to take that 0 and plug it into either one of my equations. If I did it right, it should work out the same in both. So if I put it in that second one, I get y equals 0 minus 5, which means y equals negative 5. And so then I'm going to put those two together as a coordinate, and I'm going to say 0, negative 5 as my final answer. Okay. All right, let's look at the third one. The third one is not set up the same way the first two were. Now, this one would not be difficult to do with substitution. If I wanted to do it with substitution, I would probably just move this y to the other side and have the x by itself, and then I could take what x equals and plug it in up there. But the way it is written, elimination actually would not be too bad. Elimination is where you want to add the equations together going up and down in hopes of getting one of them to cancel out. Now, right now, if I added together, 2x and x won't cancel, and 3y and y won't cancel. but I can do something to this bottom equation to make it so that they'll cancel. I'm going to focus on the y's. It doesn't, you could focus on the x's as well. But if I wanted to look at the y's, I really wish there was a 3 right in front of that y so that I would have a negative 3y and a positive 3y. Well, to make that happen, I'm going to multiply the bottom equation by 3. Everything in that equation. So I'm allowed to do this as long as I do it to everything in the equation. That's going to make this a 3x minus a 3y equals 15. Now, here's what I see kind of a lot with this method is people do this step knowing now that these are going to cancel out, so they say, okay, these are gone, and then they just focus on these two things. Remember, the reason these two things we could say canceled out is because we added the two equations together. But you've got to do that everywhere else, too. You've got to add these, and you've got to add these. Okay? And again, this equation in the middle I'm kind of ignoring now. So 2x plus 3x is 5x. And over here, negative 10 plus 15 gives me 5. And then if I divide by 5 on each side, I end up with x equals 1. Okay? So just like before, I started with one of my values. I started with my x value. Now I'm going to plug that back in to find y. And I could plug that into any of my 3 equations. I know I crossed this one out, but still works for this, like to find y, you can still use it. It just didn't matter when I was doing the adding together. So, and I think that's actually the way I'm going to go. I'm going to look at this equation, and I'm going to plug 1 in place of x. So I'm going to say 1 minus y equals 5. Subtract 1 from each side. Be careful here. Remember, this comes down as a negative y, so negative y equals 4. Now, a lot of you can just look at that and say, oh, well, y equals negative 4. But if you're not sure about that, remember, this is really a negative 1y, and then you could divide by negative 1, divide by negative 1, and y is going to equal negative 4. And so then your final coordinate would be 1 comma negative 4. Okay, so that one was done with elimination. Okay, let's look at number 4. Number 4 I would probably also do with elimination. Just anytime they're kind of stacked like this, I find elimination to be the easier way to go. So this time, just to do it a little bit differently from the previous one, let's look at the x's. Let's think about how we could get rid of the x's. To get rid of the x's, I would want this to be a negative 6. And I can do that by multiplying by a negative 2. So I'm going to multiply everything in the bottom equation by negative 2. That's going to give me a negative 6x, a positive 2y, and a negative 8. And so again, I'm kind of ignoring this equation for now. I can come back and use it later, but for now I'm ignoring it. And I'm adding together this equation and this equation. Now, my 6x is canceled. That's what I wanted to happen. That's the whole reason I multiplied by the negative 2. But in this one, look at what else happens. Negative 2y and positive 2y cancel also. Okay, double cancel out. And I didn't mean for that to happen. Okay, I just meant for the x's to cancel. That means when I'm adding these together that this whole side here is equal to one big fat 0. And then over here, 8 plus negative 8 is also equal to 0. Well, anytime this happens, and it doesn't have to be zeros, it could be any number. 5 equals 5, 10 equals 10, negative 2 equals negative 2. That means that this is infinitely many solutions. Okay? That means that in reality, these two equations were the same line. If I graphed them, they'd be the exact same line. They'd be lying on top of one another. And so any coordinate on that line would be a solution to both equations. So I could find any solution I wanted to. Okay, let's look at number 5. Number 5, our only real option for this one would be substitution, because we haven't done elimination with 3 equations. But that's okay. Substitution is going to be really easy because, look, these are both solved for variables. This is solved for y, this is solved for z. And so what I'm going to do is I'm going to take these two things. I'm going to take what y equals, and I'm going to take what z equals. and plug them both into the equation at the same time, the top equation, and that's going to give me one big equation, but it's just going to have x in it. So this equation is now going to say 2x minus 3, but instead of y, I'm putting in x minus 1, plus z, which is negative 3x plus 3, equals negative 2. So again, now it's one big monster equation, but it only has x's in it. So I'd probably start by distributing this negative 3. So now I have 2x minus 3x, and this is a negative 3 times a negative 1, so that'd be a positive 3. Now here, I put this in parentheses just to show that I was kind of putting it in place of z, but there's nothing out here that needs to be distributed. So I can really just continue here. So minus 3x plus 3 equals negative 2. I'm going to look at this whole left side and combine any like terms that I can. So I see 2x minus 3x, so that's negative 1x, minus another 3x, so that's going to give me negative 4x. And then I've got a positive 3 and a positive 3, so that's 6. Negative 4x plus 6 equals negative 2. Subtract 6, subtract 6. Negative 4x equals negative 8. And then if I divide by negative 4, I end up with x equals positive 2. Okay. Now, once again, we're not done. We do need to go back and find what y is equal to and what z is equal to. But that's easy because now we know what x is. So my y, for example, y is equal to x minus 1, so that'd be 2 minus 1, which is 1. Okay, I guess I should write y equals 1. Okay, and for z is going to equal negative 3 times 1 plus 3. That's negative 3 plus 3, which is 0. So z equals 0. Now, for your final answer for something like this, I'm totally fine with you just leaving these three separate pieces like this. But you are allowed to write these as a coordinate. It would just be x comma y comma z. So you could say 2 comma 1 comma 0. Okay? But again, leaving your answer like that is perfectly acceptable too. Okay, number 6, really, really similar here. I'm plugging this in for x, and I'm plugging this in for y, and I'm going to end up with one big equation, but it's only going to have z's in it. So here's my big monster equation, 2x, which is 4 plus 2z. Now, this is minus parentheses 3z minus 2. Remember up here I said I was putting this in parentheses, but I didn't really need the parentheses. That's because there was a plus out here. We don't really distribute a plus. I mean, we can, but it's like distributing a 1. It's not going to change anything. But here, this negative sign is going to need to be distributed. So I do stuff like this just so I'm always in the habit of, like, when I put something into an equation, I put it in parentheses so that if I have to distribute, I remember to do it. So I'm going to have all of that. Oh, and then I have a plus z still equals 6. So now there's that top equation, 2x minus y plus z equals 6. I'm going to distribute this 2, and I'm going to distribute this negative sign. So now I have 8 plus 4z minus 3z plus 2. And that plus 2 is going to be the thing that gets you, that's going to make you get it wrong here, is that negative sign needs to make that into a positive. Plus another z equals 6. I'm going to combine all my z's, so I have 4z minus 3z plus z. That's 1 plus 1 is 2. And then I have 8 plus 2 is 10, so 2z plus 10 equals 6. Let's subtract 10. So I have 2z equals negative 4. Divide by 2, and z equals negative 2. Okay. Now I need to go back and find x and y. So x is equal to 4 plus 2z, so that's 4 plus 2 times my z value is negative 2. So x is really equal to, let's see, that's 4 plus negative 4, so x is equal to 0. And my y is 3z minus 2, so 3 times negative 2 minus 2. That's negative 6 minus 2 is negative 8. And again, if you wanted to, you can leave your answer like that, or you can write it back together as a coordinate. If you do it as a coordinate, it needs to be x comma y comma z. So that would be 0 comma negative 8 comma negative 2. So it doesn't matter what order you found them in, it just matters what letters they actually represent. Okay, we do have a couple more systems, but I'll pick those up in the next video.